Morning, everybody. It is about 8 minutes until we are starting. So if you are indeed watching this on a recording, feel free to fast forward about 8 minutes and we'll be just fine. Start up in about 8 minutes. Good morning again. Starting up in about 3 minutes from now. 3 minutes from now. Our esteemed valedictorian has joined us. And Colleen, you made it. Great. Congratulations, Colleen. You have joined the Ryan Brar Club. People texting me at 2 in the morning. Your text was a lot less annoying than Ryan's are usually, though. He just usually texts me and say, "Hey, McPhinney, when are we going to hang out? When are you inviting me to your place?" Oh, I don't know, Ryan. How about 2000 and never? Yeah, just getting a couple more weeks. You guys are out of here. No, oops, Colleen. It was amazing. Jaden Senga, good morning. Sawyer, Rohan, Mark, the charismatic Bardwa. Danny, welcome. Jayhawk, salutations. Kyla. Well, I was awake at 4 a.m. Yeah. I get up early so I can think about math to start my day. Usually do my math stretching exercises from 4 till 5. And usually go for a run from 5 till about 7 or so. Run a couple hours. And usually a swim after that, followed by stringent heavy weightlifting. Yeah. 3-4 hours of physical workout and an hour of math workout. Gets me all ready for the day. All right, we will be starting 1 minute from now, and it will be amazing. Yeah, I think this is actually the same music that was playing last class, too. Sabir's Jam. Okay, here we go. We are set. We got 22 seconds until we start up. Good morning, Sabir and Katie. And there we go. We are set. It is time for your third last class. You go, what? What do you mean? Well, we've got our third last. I guess we could still do some online classes, but what's going to be happening is that this week we're going to wrap up integration. We then have 3 weeks where I am at school. So starting June 1st, teaching is back at school. Your regular online lessons are now, well, again, it depends which class you have. Some of you with other classes, you know what I'm talking about, might have different schedules, but online learning is supposed to now happen between 8 and 11. And then teachers at the school from 11:45 until 2:30. So basically morning time on regular Yale hours, you are expected to be learning online. And then after lunch, we are expected to be at the school. But the school is not supposed to be new instruction. We've been told very directly, the afternoons after 11:45, that's for students to have time to go visit whatever class they want and get help with whatever they want. So if there is a certain teacher having actual lessons, they are demanding that you come into the school to do something. You're not supposed to be doing that either. There's to be no labs. There's no computer labs open even. If you are to be doing computer work at school, you bring your own computer. It's a good time. So as far as math class, what is going to happen is I'm going to have like a sign up sheet. I will let everyone know what the sign up times are. I'm thinking half-hour intervals. If you want to sign up for more than a half hour, you can do like 2 half hours back to back, doing some quick math. That would make that an hour. So you can sign up from, say, noon until 12:30 that you want to come in for help. I'm only allowed to have 6 people in the room at one time. So I'll probably make calculus blocks so that I can just help everyone at once in the same thing. Calculus block maybe from 11:45 to 12:45. So 2 different half-hour sections, pre-calc 12, and then my workplace class. We can wrap up the day with a 5-minute extra help session for anyone wanting to come in with that class, and we'll be good. So I'll be I will let you know what it is, and then you can choose to come in Monday, Tuesday, Wednesday, Thursday, or Friday. I will be there all those days. That's how it's going to work. So after this week, there are only 3 weeks of school left. We are done. You are done, and I just figured since you guys are leaving the school, I'm going to go too. If you guys aren't there, there's just no point. So I will graduate with you. Here it is, your one of your last new lessons on integration. I'll do another new lesson Wednesday and another new lesson Friday. We'll touch on 2 more things that integration is used for. We're doing all our indefinite integrals right now. We will do definite integrals on Wednesday, and then we'll have some applications, word problems on Friday. So that's it. Then we are done with calculus. What you will be coming in for at that point then would be any topic in calculus you want. So if you say you're going to come in June, we can discuss derivatives. We can discuss more applications of integrals. We can review. We can do whatever you want and just talk about calculus. So here we go. We will do more integrating, but this time we're going to make them a little more fun. I mean, they were fun to start with, but now more fun. What if I asked you, and that 2, I did change it. I must not have saved my changes. That 2 that's after the 2x plus 1, that is supposed to be a square. So if you're looking at that, it should be squared. This should be 2x plus 1, and then all squared. So I don't know what's going on with that. But that 2 that's after the bracket and before the dx, that's a square. Okay. Up next, let's see what to actually do with this. If you get something that is all squared, just like with derivatives where we could have used Emma's rule, take the 2 down, but then multiply by it gets a little trickier with stuff like this. With integrals, there is ways to do it. There are ways to do it, but here we go. First thing you'd want to do is square what you have there. So 2x plus 1 all squared. So again, my apologies, that 2 looking so weird. The 2 is supposed to go up into the sky. So when we do 2x plus 1 times 2x plus 1, we'd end up with 4x squared plus 4x plus 1. That's phantismo. From there, now we can integrate each step. So remember how to integrate. Right now it's 4x squared. We add 1 to the exponent to make it a 3, and then divide by 3. You have 4x, which is next. Add 1 to the exponent to make it a 2, and then divide by 2. You have just a 1 all by itself. So that's a 1x to the 0. Add 1 to the 0 to make it 1x, and then divide by 1, and we would have got that. Wonderbar. 4x squared, add 1 to the exponent to make it a 3, then divide by 3. 4x, that's x to the 1. Add 1 to the exponent to make it 2, and then divide by 2. 1, x to the 0, add 1 to the 0 to make it x to the 1, and then divide by 1. We're going to get just x. And then don't forget the plus c. Amazing. Let's try another one that's fun. What if I told you f prime of x equals 2x and f of 1 is 4? This is where the notation gets really interesting. Because notice the f prime of x. If you have f prime of x, that must mean that it's the derivative. So the derivative of something was 2x. Now this f is without the prime, which means that's the original function. So I'm dealing with 2 functions. I have f of x and I have f prime of x. How can I go? I need to find f of 1. But right now I have a derivative. It's f prime of x. How do you go from a derivative back to the original function? That's right, math fans. It's the antiderivative. That is what they're called, actually, sometimes. Antiderivatives or an integral. And so we need to find c. Notice in the last example, we took an integral and there was that lovely c at the end. Well, now today we're going to actually see how to find these c's. Let's have a look at that. F of x must be the integral of the 2x, because if f prime of x is 2x, that means that's the derivative. I'm going to undo the derivative by taking the integral of 2x. That will undo the derivative or undo the prime, giving me just f of x. I take the integral of 2x. How do you do that? Add 1 to the exponent and divide by 2. There you go. Add 1 to the exponent and now divide by 2. I get 2x squared over 2. The 2's will cancel. I end up with x squared plus c. So that is what f of x actually is. Can you actually find what c is? Sure can. Look up at the top. In the question, I gave you that f of 1 equals 4, which must mean f of 1 is 1 squared plus c, and that's 4. Is it clear to you that c must? It's got to be 3, and that's how you can find c. So we're going to do a couple of these now, and I'm going to give you a worksheet with some more things like this on it. Some great, great stuff. Our next equation, our next example. Ooh, lovely. Find f of x. That means find the original function. If f double prime of x is 12x squared plus 6x minus 4, and you're told that f of 1 is 1, and you're told f of negative 1 is 5, what does that even mean? Well, if I've given you f double prime of x, what have I given you? I've given you the second derivative. We took a derivative twice and ended up with 12x squared plus 6x minus 4. Well, how can we possibly get back to our original function? I took a derivative twice to get to f double prime of x. To get back where I'm going, that's right, to undo your derivative twice, we're going to have to integrate twice, or take a double integral. Now, we could use all our fancy notation and just put 2 integral signs at the front, and then you could put dx at the end, but all good. F prime of x now must be the integral of 12x squared plus 6x minus 4. Notice I should have a dx at the end to indicate that I'm taking with respect to x, so that's missing in this one. So let's watch our notation. I gave you f double prime of x, which means the second derivative. Notice this notation. This is f prime of x, a single prime, which means I've integrated once to undo one of those. So go ahead, right where you are, right now, right where you sit or stand or are laying down in bed in your pajamas still. No, I can't see you, I'm guessing. Integral of 12x squared plus 6x minus 4. How do you integrate that? That's right. Add 1 to the exponent, divide by that number. Add 1 to the exponent, divide by that number. What would you end up with? 12x cubed divided by 3, and the 12 divided by 3 would give you the 4x cubed. 6x squared, divide by 2, and the 6 over 2 would change it to 3x squared. The minus 4, when you integrate, would become a minus 4x. And now you've got a c. We don't know what that number is, but we know it's a constant of some sort. And what can we do now? We can integrate again. What? Integrate again? That's right. Integrate again. Because now what will f of x be? Look at the notation. I started with f double prime. I integrated once. I ended up with f prime. Now I'm going to integrate again. I'm going to take the integral of 4x cubed plus 3x squared minus 4x plus c. So go ahead, work ahead. How do you do that? Add 1 to the exponent, divide by that number. Add 1 to the exponent, divide by that number. Add 1 to the exponent and divide by that number. But what about the c? Well, look a couple lines ahead. What happened to the minus 4 when we integrated? We ended up putting an x there, and it became minus 4x. Well, c is just a number. Do you know what number it is? We don't. If c is 2, then this would become 2x when we integrate. If c is negative 20, this becomes negative 20x when we integrate. So let's go ahead and take the integral of 4x cubed plus 3x squared minus 4x plus c. Add 1, divide. Add 1, divide. Add 1, divide. Add 1, divide. And we would end up with x to the 4, because we had 4x cubed. We added 1 to make it 4, divided by 4, the canceled. 3x squared, add 1 to make it x cubed, divide by the 3, cancels. Minus 4x, add 1 to make that minus 4x squared, but then divide by 2, it goes to there. C, whatever constant you had for c, it now is a cx. But now we need to add another constant on the end, and this one is d, because we took a double integral. What if you had taken a triple integral? That's right. We would now go again, and we would end up with, on those last numbers, we'd end up with cx squared over 2. We'd end up with a dx, and then we'd end up with an e, another constant of integration. Well, we need to find c and d. We're good. This is f of x, but I gave you some conditions at the beginning, telling you what f of 1 was, telling you what f of negative 1 was. We can now use those conditions to find and solve for c and d exactly. Because if you remember, f of 1 just means to put 1 in there. So the x to the 4 becomes 1, x cubed, 1, minus 2x squared, that's minus 2. C times 1 is just c. And then there's your d, it's still d. And you were told at the beginning that f of 1 equals 1. Well, now do the numbers. What do you got? 1 plus 1 is 2. Take away 2. Oh my goodness. All those numbers cancel out. We are left with c plus d equals 1. Let's try our f of negative 1. Put negative 1 in. Negative 1 to the power 4 is 1. Negative 1 to the power 3 is negative 1. Negative 1 squared is positive 1 times negative 2 would give you negative 2. C times negative 1 would be negative c, and there's your d, and you were told at the beginning f of negative 1. That's right, f of negative 1 is 5. So now look at all your numbers. 1, take away 1, that cancels. You got negative 2 minus c plus d. Well, that minus 2 can come to the other side and become a plus 2. So now we can solve using a system of equations. That's right, we're going all the way back to grade 11 on this one. Look at f of 1 again. 1 plus 1, take away 2, that all cancels. Can you see that c plus d is just 1? Good. Excellent. F of negative 1, 1 minus 1 cancels. So wipe that out, and the minus 2 can come to the other side and become a plus 2, giving you 7. We end up with the following system of equations. F of 1, 1 plus 1 minus 2 plus c plus d. Add up everything you can. That just changes into c plus d equaling 1. And then f of negative 1, the 1 minus 1, take away 2, minus c plus d. Bring that minus 2 to the other side. We end up with minus c plus d equals 7. Do you remember grade 11? Do you remember solving systems of equations? This one, super simple to solve. If we add these two equations together, c plus negative c That cancels out. Amazing. D plus D, that's 2D, and 1 plus 7 is 8. We solve this system of equations by making 2D equal 8. We can now solve for D, even without a calculator. 8 divided by 2 is 4. That's great. So now we've solved for D. Well, now look at the first equation up there. C plus D equals 1. Something plus 4 must equal 1, and I think that must mean C is -3. Now we know what C and D are. We can substitute those back into f of x, giving us our final answer of x to the 4 plus x cubed minus 2x squared minus 3x plus 4. Amazing. All right. That is it for today. A little bit of looking at integration and seeing what we can do with solving these C's and D's. So let's see what I've got for you. A nice treat again. I'm going to send you an assignment by email. 6 multiple choice questions, and I'm giving you the answers. Do those 6. Mark your own. Within 48 hours, send me a mark out of 6. That's mark with a K. Send me a mark out of 6 by Wednesday, please. Wednesday, I'm just marking that down. By Wednesday, send me a mark out of 6 on the multiple choice questions. Now, that link I gave you that you should still have on your computer to an assignment, if you look at that assignment, you are now able to do questions 22, 23, and 24 as well, just for laughs. It's not part of your assignment, but I'm encouraging you to try 22, 23, and 24 from that previous link I gave you. Anyone still needing that link to be sent, you can give me an email and say, hey, or just text me at 2 in the morning. I'll answer. Send your score out of 6 to me by Wednesday at 11 a.m. That's when our next class is. We're going to start looking over all these integrals we've been doing, but we're going to change it up. These are called indefinite integrals because I'm asking you to integrate just the whole general equation. What we're going to start on Wednesday is looking at something called definite integrals, where there is a very set space and time we are looking this over. Think of it as a derivative, but instead of just taking all of the derivative of x squared, what if I only asked you to look between certain, like from 0 to 2 or from something? That's kind of what we're going to be doing, is looking at integrals, but with a very, very definite finite domain. There you go. I will send you this assignment. It will be tremendous. 2 classes left online, and then we delve into the final 3 weeks where it's going to be sort of you exploring some calculus topics that I am suggesting to you for fun and games. Here it is. By Wednesday, send me your score out of 6 before Wednesday. And then class, as you see, is Wednesday, because I can't spell Wednesday right. I think what happened is I tried to change the word Friday, and no, that would have had a D in it also. In fact, most days of the week rhyme with the word day. So anyway, I just can't type. Send me your score out of 6 before Wednesday. I'll send you the assignment now. Stay safe, everyone. Next week, we are back in school. But until Wednesday, thank you and good night from NBC News.